Hey guys, it's Debbie Potts. Today we're going to dive into what is a metabolic analysis and geek out a little bit with some exercise physiology review. Enjoy the show.
Welcome to the Low Carb Athlete Podcast, where we focus on discussing topics to help you burn fat, optimize health, and improve performance in life and sports. Transform the whole you from the inside out with the holistic method. Let's dive in. Here's your host, Debbie Potts.
Hey guys, it's Debbie, and I just wanted to give you a quick little message from one of our sponsors, Element. It's spelled L-M-N-T, but pronounced Element. If you haven't heard about this, Element is a tasty electrolyte drink mix with everything you need and nothing you don't. That means there's a lot of salt with no sugar, and it's formulated to help anyone with their electrolyte needs and is perfectly suited for those doing a keto, low carb, or paleo diet. And I think this is great for athletes, especially in the summertime and when you're training in warmer climates. Element contains a science-backed electrolyte ratio of 1,000 milligrams of sodium, 200 milligrams of potassium, and 60 milligrams of magnesium. None of the junk, no sugar, no coloring, no artificial ingredients, no gluten, no fillers. That's it. I like the unsweetened one because the other flavors do have a little stevia, but stevia doesn't do well in my body. So I prefer the unsweetened Element. And I like the packets because I can throw them in my bike bag when I go on a long bike ride or when traveling. And I can just dump a packet in my water and it keeps me so much more hydrated. Because remember, we don't sweat out water, we sweat out minerals. So check it out. You've got a nice little gift from them if you use our discount code Drink Element. I'll put the link in the show notes. But using the code Low Carb Athlete, you get a free gift with purchase. You get a free Element sample pack with any order when you order with Low Carb Athlete on our special URL code. So support the podcast, support Element. It's backed by science and we love what they're doing. So try it out. All right, I was listening to Peter Attia's new podcast episode on my car ride to and from my master swim workout yesterday and today, and I still need to finish it. I keep replaying everything, but it was a great, intense conversation on how to do metabolic testing for peak performance and talking about fuel sources used and all the stuff I've been trying to dive into on and off here on this show as I used to do New Leaf metabolic testing back in, 2005 on and off through 2012 when Lifetime Fitness purchased the company and dissolved the use of any equipment that we had owned back then. And then Pinoy metabolic testing cart I've been doing here in Del Mar, Solana Beach, North San Diego, and now Encinitas. And I wanted to just touch on some information to help understand if you are curious about the information we learn. And you can go back to my 2 episodes I did with Daniel Crumbach, explains a little bit more on metabolic assessments, as well as with Panos, one of the co-founders of Pinoy, the company out of Greece. So just to review some information for some of you, or maybe it's new for you, this is what we learned in our metabolic analysis course, and I did Bob Seebehor's course years ago on metabolic efficiency testing to be a metabolic efficiency specialist. And it's always good to go back to review exercise physiology, as college was a long time ago for me, and it's always nice to refresh my brain as I get brain overload of learning so many different things and studying so many different topics. So I always like to do these rabbit hole podcasts more for my own benefit. So if anyone listens to, that's great. But I enjoy doing these shows. So what is metabolism? So we learn metabolism. It's a set of life-sustaining chemical reactions or processes in organisms. We have 3 main roles of metabolism. 1 is conversion of food to energy to run cellular processes. Number 2, conversion of food or fuel to building blocks for proteins, lipids, nucleic acids, and some carbohydrates. Then the last one of the main rules of metabolism is elimination of metabolic wastes. And we learn that when we exercise hard. So how do we connect what is metabolism to exercise? Here's what we learned. Metabolism refers to the processes your body uses to break down nutrients, form compounds the cells can use for energy, and use those compounds to fuel cellular functions. Your body secretes enzymes to break down food into sugars, proteins, and fats. Then each cell of your body can take these in and use them in aerobic or anaerobic metabolic processes to form ATP, which is a fuel source used in the cell, mitochondria. The calories from food are burned in this way to produce energy in each cell. So we want to maximize that. The body's overall metabolism includes muscle contraction, breathing, blood circulation, maintaining body temperature, digesting food, eliminating waste, and the functions of the brain and your nervous system. The rate at which you burn calories is called your metabolic rate. So the cardiovascular system, the respiratory system, and your metabolic system, muscle, are the three key systems in exercise that are directly measured when we do metabolic analysis. We're measuring cardiovascular, heart and the lungs, with our respiratory, lungs, and muscle health, metabolic measurements. So let's dive into each one of those. Just to review, this is a summary. The cardiovascular system refers to three things: heart, blood vessels, and the blood. Blood contains oxygen and other nutrients which our body needs to survive. We know that. The body takes these essential nutrients from the blood. At the same time, the body dumps waste products as carbon dioxide back into the blood so they can be removed, metabolic waste. The main function of the cardiovascular system is, therefore, to maintain blood flow to all parts of the body to allow it to survive. Now, we have what my mentor Daniel teaches, the plumbing, the heart, and we have the electrical system. So the plumbing system in our heart, we have so many valves. Electrical, we have these nodes, and anything affecting carbon dioxide, stroke volume, or heart rate. Now we have vessels. We have a number of capillaries, which we want to get more of. This can be negatively or positively affected by how we train. This affects our oxygen delivery and our carbon dioxide extraction. So, the more capillaries you have, the more oxygen delivery you have and extraction. So we get into the blood, decreased number of red blood cells, decreased unhealthy hemoglobin. So if we have low iron or B12, which is why I always like to do a blood chemistry assessment with my clients, along with this metabolic testing, as well as a full thyroid panel, and ideally a Dutch hormone test, and ideally a wheat zoomer and a GI map or Genova diagnostics gut test. Really helps us see the whole picture. What's going on with you to be fit and healthy from the inside out, which is my focus on this podcast, to help you be the best version of yourself, to thrive as we age and not struggle. So we're gaining tools how to do that, taking ownership of our health and creating our ideal future self. So then we have the respiratory system. The human respiratory system consists of the lungs, inspiratory and expiratory, so inhaling, exhaling muscles, responsible for taking in oxygen and expelling carbon dioxide. The primary organs of the respiratory system are the lungs, which carry out the exchange of the gases as we breathe, oxygen in, carbon dioxide out. The lungs work with the cardiovascular system to deliver oxygen-rich blood to all the cells in the body. The blood then collects carbon dioxide and other waste products and transport them back to the lungs, where they're extracted from the body when we exhale. Body's pretty amazing, isn't it? So what are the functions of the respiratory system? Number one, to provide a continuous and adequate supply of oxygen to the tissues. Number two, to enable the removal of carbon dioxide from the body. Assist in maintenance of the acid-base pH balance of the body. Assist in controlling our body temperature. And core stability during exercise. You wouldn't know that or think about that. Now, we've got the muscular metabolic system. Now, this is where the structures within the muscle are associated with muscle metabolism. We're talking mitochondria and the capillaries. This is what we keep talking about, or I talk about with clients, I guess, mitochondrial density. This refers to the number of mitochondria and affects to the amount of ATP that can be produced to create energy for activity. So you might think, oh, mitochondria, I need more of them. Capillarization refers to the number of small blood vessels which can transfer oxygenated blood and fuel to the muscle and take away the carbon dioxide by maintaining homeostasis at the muscle. Just crazy. Our body's own innate intelligence does all this. We don't even have to tell it. It just does that. So you can look up great infographics on the muscle and looking up the inside of the muscle and of each muscle fiber, the cell, and then going to look at the capillary. And then the myofibrils and the myofilaments. It's just crazy. Learned all this in college in exercise physiology many years ago. Now, I'm using that knowledge or remembering how to apply it with metabolic testing. Now, mitochondria, we've learned a lot about lately, right? Mitochondria capacity, density, taking care of our mitochondria. We see the picture of a cell and these squiggly lines representing a mitochondria, or mitochondria. Why? These are the most important parts of the structure and the function of muscle, specific to muscle metabolism. Mitochondria. Muscles need ATP, as well as calcium, sodium, and potassium for the muscle to contract and relax. ATP is created within the mitochondria via the use of oxygen, aerobic, the nutrients delivered by the hemoglobin via the cardiovascular system. So ATP is created within the mitochondria with oxygen, and the nutrients needed, right? We need to create energy to survive at rest and during exercise. Mitochondria are also used to create ATP from byproducts created through what we know as anaerobic metabolism when enough oxygen is present and when energy production rate isn't beyond capabilities. So mitochondria is used to create ATP from byproducts created through anaerobic metabolism. What do you think that is? Lactate. Now, we've got veins, arteries, capillaries. Veins are blood vessels which carry deoxygenated blood from the body back to the heart. Blood in the veins is low in oxygen as it's been taken out of the body and high in carbon dioxide as the body has unloaded it back into the blood. Now, arteries are blood vessels which carry oxygenated blood from the heart back to the body. Blood in the arteries is oxygen rich as oxygen has been reloaded onto the hemoglobin at the lungs. Now there's microscopic blood vessels which connect arteries and veins together, called capillaries, that allow oxygen delivery and carbon dioxide extraction within our muscles. Training can increase or decrease the number of capillaries available at the muscle, therefore can influence oxygen delivery and utilization. Amazing. Okay, let's go into the energy systems. I really want to share this diagram. I'll have to find it online, but it's a pretty great picture of substrates, carbohydrates, fatty acids, amino acids. What fuel source are you burning at rest and during exercise at various intensities? This is the main reason I think it's important for everyone to do testing that is striving to improve fat loss, body recomposition, performance gains. Obviously, people know testing for that, but I don't think that's as important as people trying to figure out their exercise, nutrition, lifestyle habits to improve body composition or weight loss, fat loss, ideally. We want to raise lean, increase lean body mass, decrease fat mass. And then, of course, performance in life, the longevity markers, metabolic health, improving the aging process. So we have free ATP. We've got the phosphagen system, glycolysis, and oxidative phosphorylation. So we know oxidative phosphorylation, you might have heard, is using fatty acids via beta oxidation, go through the Krebs cycle, create lots of ATP. Then we get a little higher intensities, zone 3 and higher, we're burning more glucose because remember zone 2, when I do testing, bottom of zone 2 is your peak fat burning or your fat max. Top of your zone 2, when we figure it out in testing, is a metabolic crossover point. Where's the fat starting to decrease and the carbohydrates are coming up. So we find that point in time, roughly around there. That's not exact, right? That's going to change if you're outside versus inside, various reasons. And then zone 3, we're just burning more glucose, but we're still burning some fat, but mostly glucose. So glycolysis, we're creating ATP, energy from glucose, into pyruvate. And then we get the little more higher intensity into zone 4. That's where we gain the phosphagen system, creatine phosphate, creating some ATP, but it's quick because you're doing sprints and we're getting zone 5. You're getting more of the creatine phosphate energy system. Sprint training and heavy weightlifting is more that power. Zone 4 is going to be more shorter duration, sprints, and power. So 400-meter run versus 100-meter sprint in zone 5. And then we've got the lower zone, zone 2 to bottom of zone 3 is more your endurance, walking, easy run, marathon. We're just going so we can keep going. That's where we want to train as endurance athletes. Now, going into the meaning of each, aerobic ATP is created from having oxygen on board. Aerobic metabolism fuels most of the energy needed for longer, low to medium intensity exercise. The aerobic metabolism, the system functions using the Krebs cycle, a complex, very complex series of chemical reactions that use oxygen to convert nutrients to carbon dioxide and ATP that provides energy for muscle contraction. This also contributes to the anaerobic system through the electron transport chain, ETC, by taking pyruvate back into the Krebs cycle to make more ATP. Fascinating. So anaerobic system, we can still get more ATP in the Krebs cycle, taking pyruvate back in and getting more fuel. As we get higher intensities, more anaerobic, ATP is created without oxygen. Anaerobic metabolism occurs during shorter bursts of higher intensity exercise. When energy demand rate is higher, then it can be provided through the aerobic system. So ATP production rate drives what fuel system provides a majority of the energy, and they never work in isolation. So they're always a little overlapping. It's not just one or the other. So we have a little bit of each, especially as you go zone 2 to zone 3. You're never just burning during exercises. I've known and been taught and seen in testing 100% fat. There's always some carbohydrates in there. And hopefully you'll get Joe Friel on the show in his new book. He was talking in a seminar last week in San Diego that you're burning lactate all the time, a little bit, even at rest. So ATP production drives our fuel system, the rate of ATP. So that will change. If you can't keep up, you're doing those sprint interval training, your fuel source is obviously different, how you're getting that energy, than the long, slow, sustained distance or long, sustained distance. So we have aerobic sources, free fatty acids, beta oxidation via the Krebs cycle. We are using some carbohydrates, amino acids, protein if required, hopefully not. And by a product of glycolysis, pyruvate is oxidated to create lactate as a byproduct, and then through the Krebs cycle and the electron transport chain. So that's where it gets complicated, exercise physiology, Krebs cycle nightmares in college. But the fascination is that you still can create some extra fuel, not just free fatty acids, but we can get some of the glucose, carbohydrate metabolism, glycolysis, and then pyruvate oxidated to lactate. Crazy. Anaerobic sources. Stored ATP, phosphocreatine, glucose from carbohydrates, phosphorylation, and these are all different names for the same systems. Anaerobic sources, stored ATP. Anaerobic or the phosphagen system, or ATP, PC, or it's called CRP. So you're getting phosphagen system. It's also known as ATP, PC, or CRP. That's going to be helpful in figuring out our fueling in different zones, because zoning is based upon the fuel sources we identify during the test. After we do the test, we analyze the data. You must be able to identify which intensity you change from one primary energy system to another. So we can see that changes in your volume of oxygen and carbon dioxide and respiration through our metabolic analysis. So we're finding your 5 zones based on this fuel source. If you're doing beta oxidation, getting the fatty acids, where you're starting to get more glucose used as fuel with that metabolic crossover point, and we start to see that increase in intensity, and then we go from more from glycolysis to more phosphagen system, or the ATP PC, or you want to call it CRP. So lactate versus lactic acid we learned about. Pretty big topic is lactate threshold testing. That is a measurement, a blood prick during a test on a treadmill or bike or whatever exercise you're doing. Test what your lactate is in your blood. That level, what was it, supposed to be under 2, and that is being used as a simple way to figure out where you are keeping your lactate levels low. Is it telling you how much fat you're burning versus carbohydrates? No. It's helping you figure out where you're accumulating higher levels of lactate in your blood. So lactate is a byproduct of glycolysis. So when we are going higher intensities into zone 3 and higher, lactate is a byproduct, remember, of that glycolysis, pyruvate making lactate is a byproduct. So it is giving us fuel back in that Krebs cycle to create more ATP. I'm not obviously an exercise physiologist, but this is what we learn. Lactic acid breaks down into lactate and hydrogen ion. Hydrogen ion that causes the acidosis that drives increased respiration. Hydrogen ions are used in the electron transport chain to create ATP, H2O, also known as water, and CO2, carbon dioxide. Lactic acid is usually blamed for the muscle soreness due to acidosis, but it's not lactic acid that you should be blaming. It is accumulation of hydrogen ions that have been identified as one of the main causes for the change in our pH levels. So we're more acid in our blood, acidosis. And this is connected to muscle fatigue. So it's not lactic acid, it's the change of the blood pH level because of the accumulation of hydrogen ions. Hydrogen ions, I said, are used in the electron transport chain to create energy. So byproduct of breaking down lactic acid into lactate and hydrogen ion, it's the hydrogen ion that causes acidosis, not the lactic acid. Lactate, hydrogen ion. So does that make sense? Lactic acid is usually blamed for muscle soreness due to acidosis, but again, it's accumulation of hydrogen ions that have been identified to create that burning muscle fatigue you feel maybe end of a race. Now, aerobic metabolism and respiratory systems are the most important systems for being able to process hydrogen ions and lactate and maintain the pH and therefore be able to continue exercise at that higher intensity. So how do you train? That's doing some zone work. So what we learned was intracellular acidosis is due mainly to lactic acid accumulation, has been regarded as the most important cause of skeletal muscle fatigue. Recent studies on mammalian muscle, however, show little direct effect on acidosis and muscle function at physiological temperatures. Instead, as we just went over, it's an inorganic phosphate which increases during fatigue to breakdown of creatine phosphate appears to be a major cause of muscle fatigue. So you can look up article, it's muscle fatigue, lactic acid or inorganic phosphate is the major cause. That's back in 2002, a long time ago. So what did you learn? Or inorganic phosphate increases fatigue due to the breakdown of creatine phosphate, appears to be the major cause of muscle fatigue. So what do you do about it? That's how we train. So does acidosis cause muscle fatigue? We're learning no, it's anaerobic breakdown of glycogen leads to intracellular accumulation of inorganic acids. Lactic acid is quantitatively the most important, this article says. Since lactic acid is a strong acid, it dissociates into lactate and hydrogen ions. Lactate ions would have little effect on muscle contraction. However, the increase in hydrogen ion, reduced pH or more acidosis, is a classic cause of skeletal muscle fatigue. However, they say, the role of reduced pH as an important cause of fatigue is now being challenged, and several recent studies show that reduced pH may have little effect on contraction of muscle at physiological temperatures. So, does the body maintain pH well through the use of hydrogen ions through electron transport chain or the extraction of hydrogen ions through your respiratory system through carbon dioxide expulsion? So it's, I think, looking at how we should train and working on that recovery into zone 1 from that zone 3, 4, or 5 interval, long, medium, or short intervals you're doing, making sure you come back into zone 1 in between those pieces. So last part of this article says, besides acidosis, anaerobic metabolism and skeletal muscle also involves hydrolysis of creatine phosphate to creatine and inorganic phosphate. Creatine has little effect on the contractile function, whereas the several mechanisms by which increased phosphate ion may depress contractile function. Thus, on the basis of recent findings, increased phosphate rather than acidosis appeared to be the most important cause of fatigue during high intensity exercise. So considering they say that muscle fatigue usually happens at extremely high intensities where creatine phosphate would be the energy source, this theory is being considered. So muscle fatigue at high intensities, maybe it's the phosphate part of it when we're using that sprint interval training creatine phosphate. All right, so the energy systems selected is not based upon availability of oxygen, but driven by the intensity of exercise, and therefore the energy rate of production of ATP that is required at that intensity. The Krebs cycle for aerobic respiration is dependent upon the number of mitochondria and capillaries available within the muscle cell, as well as oxygen and nutrients offloading from the hemoglobin. Now, oxygen is required during aerobic respiration and process fatty acids, carbohydrates, known as glucose, and protein through the Krebs cycle, and process anaerobic byproducts as pyruvate into lactate through electron transport chain. Most oxygen used at the muscle is during anaerobic metabolism, so the term anaerobic metabolism is misleading. So most oxygen used during the muscle is anaerobic. So it's not that we're actually anaerobic or aerobic. It's not what we should be concerned about. Interesting, right? We're taught anaerobic. So lactate, the point of this article, to teach you that lactate is a fuel in the presence of oxygen. Therefore, your aerobic fitness is vital to higher intensity exercise. Your respiratory system is vital to processing hydrogen ions and therefore to maintain pH balance in the ability to perform exercise. Lactic acid does not cause muscle fatigue. We think higher levels of hydrogen ions can cause muscle fatigue, possibly due to the changes of the muscle or pain response from the nerve fibers within the muscle. So inorganic phosphate created during creatine phosphate energy system could be the cause of muscle fatigue. Interesting. So that is geeking out into the different systems. We talk about delivery versus utilization. So we have our cardiovascular system and our respiratory system are delivering energy, blood, oxygen, and utilization is their metabolic system, the muscle. So one or more of these three systems can limit your performance. So when we do testing, we're identifying what system is holding you back from being your best self. So the good analogy where we're taught that supply is loading the truck. Respiratory system are the lungs. The lungs supply the oxygen in the blood, hemoglobin. Cardiovascular, hemoglobin delivers the oxygen and the fuel to the working muscles via the heart and the vessels. So loading oxygen from the lung into the hemoglobin for delivery to the muscle. And then we have to unload it. So muscular metabolic system unloads the oxygen and utilizes the oxygen at the muscle. So we have utilization is unloading the truck. Unloading, utilizing oxygen from hemoglobin in the blood at the muscle, right? And then we've heard from years ago, I interviewed Tim Noakes, Professor Tim Noakes, pretty amazing, fascinating person. The central governor model. Central governor model, this is a protection of the vital organs over performance. This is Professor Tim Noakes proposed this process in the brain that regulates exercise regarding the neural brain, calculates safe exertion by the body. Physical activity is controlled so the body's intensity cannot threaten the body's homeostasis by causing anoxic damage to the heart muscle. The central governor model limits exercise by reducing the neural recruitment of the muscle fibers. This reduced recruitment causes sensation of fatigue. The existence of central governor was suggested to explain fatigue after prolonged strenuous exercise in long-distance running and other endurance sports, but ideas could also apply to other causes of exertion-induced fatigue. He wrote a book years ago, and we talked about that central governor model. So that homeostasis in the body. So muscle contraction during exercise is responsible for producing changes, including biochemical ones, as in decrease in the pH balance due to the hydrogen ions or increase in organic phosphates that we just talked about, as well as changes to the cardiovascular system, the energy system, as glycogen is depleted, blood glucose fails. Thermoregulatory system, blood temperature rises. These changes directly inhibit exercise either by causing the muscle to lose its muscle force, being able to generate force at the muscle. I said that wrong. This is the theory of hydrogen ions, phosphates, oxygen supply the anaerobic limit to exercise, and calcium ions, or by acting on the brain to force the muscle contraction levels down. This is the case with high body temperatures. Again, amazing, the body's own innate intelligence. So muscle contraction produces physiological changes: metabolism, energy supply, cardiovascular system, body temperature. Failure to maintain homeostasis results in fatigue, directly or indirectly, central fatigue. So you can go read that book he had years ago, or listen to podcasts. Now, more information we can go into. I want to go into next time leaky gut, how that's created from exercise, and that most athletes probably have leaky gut. And I think we're going to do a seminar or workshop with, forget the guy's name, on breathing and how breath work. And I was trying the swimming breath holding, and we did a seminar with Laird Superfoods at the Expo West show last week on breathing and holding your breath, box breathing, CO2 accumulation, and more. So it's really a good topic to talk about. We want to learn how to breathe more efficiently when we exercise. All right, just to wrap it up, carbon dioxide and oxygen concentrations are vital to the ability of oxygen to offload into the muscle and offload carbon dioxide at the lung. Hyperventilation leads to decreases in carbon dioxide concentrations at the muscle. This can lead to increased affinity of oxygen to the hemoglobin. This leads to decreased ability to deliver oxygen at the muscle, and this can negatively affect performance. So we want to work on our breath work, breathing, just summarize part I didn't go into, but we'll go into that more on a separate podcast. Just remember that all these systems work together. Our body works as a team. It's like an orchestra. When things off, we've got imbalances, dysfunction. So we must understand the control mechanisms of all three systems. The interaction of the three systems is complex. You must be able to test each system in order to truly identify which system is being your limitation. And that's why we do the testing. Limitation-specific nutrition and training can minimize or eliminate primary limitation, and this will help affect the other system's performance. Retesting every 3 months, ideally to help figure out, are you doing the right things, the right exercise and nutrition lifestyle habits to make those changes. So we want to see the impact on your nutrition exercise programs of each system. So we want to find the new limitation, because there's always something we need to work on. It's just an ongoing journey, and design a new program for you to follow. Having purpose to your workouts and learning about nutrient timing and learning about nutrient-dense foods that work best for you to improve performance and recovery and repair and optimizing your sleep. Really working on that holistic approach. But metabolic testing is the best method to measure these three systems and helping identify what is your limitation. And I was telling someone today, I don't think we should just focus on only athletes training for a race or big event. They need to know their VO2 max. I'd rather people test and we assess where they are now so they can figure out how to exercise. Have, again, exercise with purpose. Knowing what is your zone 2 and how you should do sprint interval training and coming down to your zone 1. So let's identify even zone 1 and zone 2 and 3 so you know where to train. We don't necessarily need to find your max heart rate for people just trying to figure out how best to exercise. So we don't have to be scared of doing a metabolic test because it's going to bring us up to my maximum heart rate. But let's figure out kind of estimated peak heart rate and VO2 max, and then we can at least see what fuel source you're burning at what heart rate and intensity and retest that. But also we want to look at your resting metabolism. What's going on when you're not exercising? How is your metabolism? Let's look at your blood chemistry markers and looking at signs of insulin resistance and signs of inflammation in your body and malabsorption and deficiency. So we want to look at the whole picture ideally, but at least know that if you have some limitations, you're trying to figure out, I'm doing all the right things, but I'm not getting the results I want. It is best to test and not guess, and figuring out what you should do right now and switch it up maybe a little bit, doing what you're not probably doing. And if you're trying to figure out what to eat, maybe you need to switch up, maybe eat throughout the day 3 meals instead of 1 meal a day, and getting the right calories in and getting that protein and figuring out how to fuel for those hard workouts. There's a lot to it. So we want to identify cardiovascular fitness, our respiratory limitations that can limit your performance. We want to look at metabolic limitations and looking at your fuel source you're using at different intensities and at rest. So metabolic analysis, it's a great way to measure each system individually and then look at analyzing each system, how one affects the other. So we need these metrics. We cannot improve what we don't know if we don't have something we can measure, getting that metrics, that baseline data. And identifying that fuel source, I think, is really helpful for a lot of people, not just fixated on my lactate levels in my blood, but looking at where am I burning the most fat? Where am I burning more carbohydrates? And figuring that out to improve whatever goals you might have. So we want to identify the training zones, allowing you to have more of a personalized fueling and training program. So find someone near you to do metabolic test and get some blood chemistry work done through your doctor. And if they don't test everything, do Ulta Labs or something as that, so we can get the whole picture. Resting metabolism, I think, is really important to do as well. This will see how many calories do you need. Are you burning fat and carbs at rest? But what's your percentage? How efficient you are? How's your breathing at rest? Are you having trouble breathing through your nose when you're lying down, or do you need to breathe through your mouth? And how are you breathing? How's your structure of your posture, and how you can improve that with certain exercises and breath work. All right, so let's go into next time, leaky gut and the athlete, because I just got all this great research on that. So sorry if this was boring, or maybe it was interesting if you like to geek out on exercise physiology, but just learning a little bit more about our energy systems, I think, is helpful, and the benefits of each one. So talk soon, and we'll dive into more rabbit holes. Hey, my fellow aging endurance athletes, just a reminder, if you like what you listened to today, make sure to share this episode with your community. Head to debbiepotts.net to set up a free discovery call to learn more about my personalized coaching programs, especially if you are on a mission as myself to improve the aging process and start training to be my best self when I am 80, 90 years old. So I am on a mission to live my best life and be my best self the second half of my life. So if you're on the same mission as me, head over to my website and YouTube channel to learn more ways to improve the whole you from the inside out with the holistic method.
Thanks for listening to the Low Carb Athlete Podcast. If you have any questions, feedback, or topic suggestions, let us know on Facebook or at debbiepotts.net. You can help us continue and grow by leaving a review on iTunes. Thanks again, and see you next time.